Okay, 33. We have two objects, a 200 kilogram object and a 500 kilogram object, separated by 0.4 meters. So I'm going to say M1 is this guy. Here's M1, 200 kilograms. And then over here we have mass 2, 500 kilograms, separated by a distance of 0.4 meters. Okay, the units are all good, kilograms, meters, we don't have to convert anything. And then what they say for part A, find the net just meaning total, gravitational force. Now what do we mean by gravitational force? All objects in the universe are attracted to each other, even if they're not attractive. Get it? Anything with mass, all objects in the universe are attracted to each other. G equals M. The gravitational force equals Gm1 m2 over r squared. That's the equation for finding the force of attraction between two objects. All right, so we have this third object. Find the net gravitational force exerted by these objects on a 50 kilogram object placed midway between them. Okay, so we have three objects total. Which of these three objects are we focusing on? M1, M2, or M3? M3. All right, so what are the forces acting on M3? Well, look, what is M1? Is M1 an object? Yeah. Is M3 an object? Yeah. So M1 is going to be attracting M3. Now look, is M3 attracting M1? Yeah, but we don't care about that because we're focusing on M3. But just so you're aware, M1 exerts a force on M3, and M3 exerts a force on M1. But we're focusing on M3. Now, I'm going to label this force F31, meaning the force on 3 by 1. Does that make sense? F31, the way you interpret that, the force on object 3 from object 1. All right, is M2 an object? Yeah, M3 is an object. So what's M2 doing to M3? Attracting it. So this will be F32. Okay, and again, look, object 3, M3 is also attracting M2, but we're focused on M3, so we don't care about that force, the force on M2. So they want the net force. So here's what you got to do. You got to calculate what's F31, what's F32. You got to find them. So how do you find F31 and F32? You go to this equation. Oh, and by the way, G, you don't have to memorize it. I'll give it to you on the test, on the midterm. It's the gravitational constant, 6.673 times 10 to the negative 11 Newton meter squared over kilogram squared. That's a constant. All right, so here we go. Let's find F31. We'll find what each of these forces are. F31, so I'm just plugging into this equation. 6.673 times 10 to the negative 11 Newton meter squared over kilogram squared. So the two masses here, so we want this mass and this mass. Okay, M1 and M3. So that's going to be 200 kilograms and 50 kilograms, right? We're finding the force between these guys. And then what's the distance separating them? The distance from M1 to M3 is going to be 0.2 meters. 0.2 meters. And make sure you square that. Oh my gosh, I can't even tell you how common it is, like on the midterm or on quizzes, where kids forget to square the R. You got to square it. Okay, so you do that. F31 comes out as 1.668 times 10 to the negative fifth. Okay, now let's find F32. F32, so we're plugging into the same equation. So this is going to be 6.673 times 10 to the negative 11 Newton meter squared over kilogram squared. So now we're doing this mass and this mass. Those are the two masses. So we go 50 kilograms and 500 kilograms. divided by the distance between them, which is 0.2 meters squared. And then that force is 4.171 times 10 to the negative fifth. All right, so which of these two forces is going to win? Basically, think about it like a tug of war. F32 is to the right, F31 is to the left. How do we find the net force? F net is going to be what? F32 minus F31, right? With our sign conventions, plus to the right, minus to the left. So basically, we subtract these two forces. You subtract them, and you get a net force of 2.5 times 10 to the negative fifth. To the right. 2.5 times 10 to the negative 5. Now, part B. So everybody good on part A? Any questions? Oh, dude. Okay, part B. So let's have to fill this in again. So M1 is 500. M2 is 200. Is that how I had it set up? Oh, darn it. M1 is 200. M2 is 500. Okay, now, M3, let's just erase this guy for a second. So here's what they're saying. Oh, and the distance of separation, M1 to M2, from center to center, it's still 0.4 meters. Okay? Now, what they're saying for part B is this. At what position can the 50 kilogram object be placed so it has a net force of 0 on it? So what does a net force of 0 mean? The force to the right and the force to the left are going to cancel. So look, is M3 going to be over on this side, or is M3 going to be over on this side? Towards the right or towards the left? To the left. How do I know that M3 is going to be somewhere over here on the left? Because what tells me that? Yeah, M1 is smaller than M2, right? The fact that this has a smaller mass, so M3 has to be closer to M1. So M3, here's our 50 kilogram guy. Now look, again, we have F31 to the left. We have F32 to the right. If the net force, right up here they say, at what position can the 50 kilogram object be placed so it experiences a net force of 0? So a net force of 0 tells us what's going to be happening to these two forces. They're going to be equal. They're going to cancel each other. Okay, so let's do that. We're going to go, all right, so in this situation, we need F32 to be equal to F31. Okay? Now what's the equation for force here? What's the equation for gravitational force? G M3 M2 over distance squared. Okay, let's deal with our distances here. Let's call the distance from M1 to M3, let's call this distance x. So what's the distance going to be from M3 to M2? That's going to be 0.4 minus x. Does that make sense? So from M1 to M3 is x. From M3 over to M2 is going to be 0.4 minus x. So this distance here, so between 3 and 2, this is going to be 0.4 minus x squared. Right? From M3 to M2 is 0.4 minus x. Don't forget to square it. Okay, so this is going to equal, now what's F31 going to be? That's going to be G M3 M1. What's the distance between 3 and 1? X, but square it. Okay, so at this point, what cancels out? The G's cancel, and M3 cancels. Okay, so what we're left with is, we're left with M2 over 0.4 minus x squared equals M1 over x squared. So cross multiply this, and you're going to get M1 x squared equals 0.4 minus x squared M1. Wait, this is M2. Oops, this is M2. That's M2, this is M1. Now, at this point, how do we simplify this? You guys are way better at math than me. How do you simplify this? I would avoid, at all costs, avoid the quadratic. There's a way to avoid the quadratic here. Square root both sides. So that's going to give you x square root M2 equals 0.4 minus x square root M1. And then you got to distribute this. So usually I tell you guys don't plug numbers in till the end. I think it's actually easier to plug numbers in here. When you plug numbers in, okay, so I'm now going to come over here. When you plug numbers in, you're going to get this. You're going to get 22.361x. The 22.361 is the square root of M2. Square root of 500. Okay, and then that's going to be equal to, so when you distribute this, you're going to get 5.657 minus 14.142x. So when you solve, the only thing missing in there is x. So when you solve this for x, you get 0.155. So that's 0.155 meters from the 200 kilogram mass.